Mr. Novak here. Today I will show you how to use your graphing calculator for graphing. Ooh. So to start with, we go either to the home button where you'll find the icon for graphing, or if you're in a document already, Control N for new. Do you want to save that other one? Say no, and you'll have your list, which is option number 2. The default for graphing function is to give it to as a f of x. We prefer the y equals at the moment. So for that, we need to go to our menu. So we click the menu and keep on clicking using the keypad. It's much easier to go menu, keypad 3, 3, 1, and you'll have your 3 options. That's the y equals mx plus c. That's our preference in Australia. We need a vertical line because remember vertical lines have a gradient of or undefined, and your xy intercept format. So let's do the vertical line first, and there it is. Just type in a number and it will do the vertical line. Now that we've selected that, it remembers that if you use the tab, which is a shortcut, and so there is the x again, do -2, and we have another vertical line. Oh, what can you say about those two lines? Think what this lesson's about. Good. So now we're ready to say do another set of equations. So to start fresh, we go menu, 1 for action, 6 to delete. So just remember that menu 1, 6. This time we're going to do a horizontal line. So we have to start over again because if we press tab we'll get x equals. So we want menu, again 3, 3, 1. And this time, yes, that's right, we'll use option 1 because the gradient of a horizontal line is 0. You will have to put that in and then the value of that equation. And now that we've put that in, we can use tab again, 0, and say 2. And again, we have 2 horizontal lines. Can you remember what was for clearing the screen? That's right, menu 1, 6. Lots of practice, and you'll get through the tests quickly. I'm just going to quickly jump to the PowerPoint. Yes, Mr. Farragut did a really great demonstration doing it manually and with pen and paper, which is fantastic. I've, at the same time, uh, some kilometres away, I was doing this. Use this for writing your notes into your summary book because you can, when you load it up, access each of the slides one by one. So remember, this one is parallel line when a point is given. So we have, that's the equation we're going to use. The problem that Mr. Farragut did with you was that, remember, we've just seen that parallel lines have the same gradient. Substituting the value of the points into that particular question. What do we do now? That's right, we expand the brackets. What do we do now? That's right, we collect the constants. In other words, the -1, we add 1 to both sides, and there is our parallel line passing through the points 3, 1. Go to the next page, and this is why I'm demonstrating, because for question 1, we are going to use our calculator. And here they are asking you to check whether two given equations are parallel. So it might go something like this. We already used the y equals mxc format, so press tab. So we'll do two equations. The first one, y equals 2x minus 5. Y equals 2x minus 5. 2 there, tab, -5, enter, and y equals tab 2x tab plus 3. enter, and you can see that they are parallel because they have the same gradient. In actual fact, if I go to with my cursor and I get the cross arrows, I can then move it without changing the gradient, and you can see, yes, they remain parallel. The only thing that changes is the y-intercept. The gradient stays the same. As soon as we grab one, we choose go down, so don't go down the end here. You can see how it's going to rotate it. We can change the gradient. And if I make that one back to 1.3, can I get it to 1.3? Depends on where you grab them, but we could get them to be the same by doing that. The other option would have been maybe to use the AX plus BY equals C, the XY intercept format. So let's clear that. Remember what it was? That's right, menu 1.6. Press yes. Now we want to check whether y equals negative x plus 1. Ooh, that's tab, y equals negative x. And if I put it just in negative x plus 1, it doesn't understand. Remember, it needs to know that in actual fact we have the implied 1 in front of the x. So we need to go back and fix that and make that negative 1. So y equals minus x is actual fact y equals minus 1x, or gradient of minus 1. We then press enter. And the other one was to put in a one in the XY intercept format. So rather than transposing it, we just simply go, menu 331, and the y-intercept method is that. And we're going to put in 3x minus 3y equals 6. 3x minus 3y, or negative 3y, equals 6. Press enter, and they are not parallel. In actual fact, if you look carefully, they are perpendicular. And there are exercises and examples shown to you by both Mr. Farragut and in the PowerPoint. So, and let's do one more thing. That's menu 1.6. Let's see how what conditions does the XY intercept format for parallel, for lines to be parallel. So we go tab, because remember we use that. So let's do 3x plus 3y equals 6. Enter. And then window tab. Let's do 3x. I'm going to keep them exactly the same. Tab 3 tab. Let's go 1. Are they parallel? So yes, if the A and the B are exactly the same, then they remain parallel. It says that they are common. It would have been simplified to x plus y equals 2. So if I go to there, and there it is, x plus y equals 2. So, but you'll never go wrong if you put the same A and B. As soon as you change that to say tab, let's go 3x plus 2y equals 6. We have non-parallel lines. And don't forget, the number on the end does not tell you where it cuts the y-intercept. Hope you found that useful. And of course, later on, when we're doing graphing, solving simultaneous equations, we'll need these skills as well. So see if you can practice that. Have a good day.